Hello everyone, my name is Amin Senov and in this class we will cover the topic inequalities. Now, in inequalities we have four signs. The first one is this sign, the second one is this sign, the third one is this sign, and the fourth one is this sign. All you need to remember is those four signs. Let me show you what each of those mean. For example, let's say we have two numbers. Let's say we have number 3 and number 5. In this case, if we compare those two numbers, 5 is greater than 3. This is the use of the first sign or symbol. Now, I can also say that 3 is less than 5. It's the same thing, but we can use it this way too. And when it comes to other numbers, let's say we have an imaginary number x. I will explain what it means. So this x, let's say it's greater than or equal to 5. What this means is x can be equal to 5. It's minimum value. It cannot be less than 5 because it's either greater than or equal to 5, right? So it can be 5, 6, 7, and plus infinity. Like you can go onwards however you want. It can be equal to 1 million. It's possible. Also, at the same time, we can use the sign. For example, x is less than or equal to 5. In this case, again, x can equal to 5, but it will be its maximum value because x is either less than 5 or it equals to 5. So x can be 5, 4, 3, 2, 1, 0, and negative infinity. You can go onwards however you want. It can equal to negative 1 million, for example. But the difference between these two signs and these two signs is if I write x is greater than 5, you cannot pick 5 for the solution. You have to pick minimum of, let's say that x is an integer. Integer is values that are whole, basically 0, 1, 2, 3, 4. But we also have, for example, 2.5. This is not considered an integer because it has like 0.5 right here. So in this case, x cannot equal to 5, but it can equal to 6, 7, 8, 9, 10, and so on. It's the same thing with another sign, which is this sign. In this case, again, x can never equal to 5. The minimum value will be x equals to 4, 3, 1, and so on. I hope you can see the pattern and you can see the difference. In this case, for us, a solution, let's say I wrote this. These numbers are considered our solutions. And we can actually write everything in decimals. Let me demonstrate some examples. Let me say 3x plus 9 is greater than 6. Let me make my screen a little bit bigger. So, when you write with this sign, you will see that the borders are kind of weird. They're not lines. They're basically numerous amount of dashes. If you zoom in, you can see it's just like dashes, right? They have a little space between them. This is why you can never pick, for example, this as your answer. Whatever touches this border is not considered your answer. When we have only one equation like this and when we plug it into decimals, for us, a solution or plausible values are considered the colored parts. So wherever it's red, those values are considered fine for me. If I change the sign to greater than or equal to 6, again, let's choose 6. As you can see, those dashes, they disappeared and just like a straight line appeared. our border is now straight without any separations. In this case, you can actually pick -1 as a correct value. It is as if saying, let's say we have two things. X is greater than 5, or x is greater than or equal to 5. Now the minimum value of x, in this case, let's assume it's an integer, it will be 6. But in this case, it will be 5 because you have this equal sign right here. I hope up until here you understood everything. But the situation changes when we have two lines. Let me show you what I mean by that. Let me again open Desmos. Let's say we add another line, which is 8x minus 3 is less than or equal to 34. In this case, because we have two lines, as you can see, we have two colors. One is blue and the other one is red. For us, a solution is considered the points where both of those colors fall. It will be from here up until here. As you can see, because in this area right here, blue and red, they fall on top of each other. This is considered our solution. But again, let's just change the signs. In this case, unfortunately, you cannot pick -1 and 4.625 as your solutions because they are your borders and your borders are like dashes. Just remember it that way. Great, I hope you understood everything up until now, and I think we can start solving some questions. Let's solve this first question. I will show you one example of how you can solve it by hand, and then I will start using Desmos because I would highly suggest you to use Desmos for this type of questions. It will save you a lot of time. So, y is less than and y is greater than. Let me write it in this pattern. So, I will put y in the middle and I will write like this. So, y is greater than this, right? I will write this in the left part. It's the same thing, I'm not changing anything. It's as if saying 5 is less than 10 and 10 is less than 12. I'm doing the same exact thing right here. Okay, and we are also told that y is less than -2 over 3x plus 4. So I will write it in this part. Now, what will we do next? Let's take one example. Let's take answer choice A. When I plug in 6, I have to plug in 6 for every time I see x. Let's do it. We'll have 2 over 3 multiplied by 6 minus 2 is less than y, and y is less than -2 over 3 multiplied by 6 plus 4. And if I actually multiply them, let me multiply them. So it will be 12 over 3, I'm basically multiplying, minus 2, -12 over 3, plus 4. And let me divide 12 by 3, which is 4, right? It will be 4 minus 2y, and -4 plus 4, right? And if I simplify it even more, we will simply get 2 is less than y, and y is less than 0. This is not true, right? How can y be less than 0 and at the same time be greater than 2? It's as if saying that, let's say we have 1. In this case, we're technically saying that 1 is less than, let's say, 0, but at the same time, 1 is greater than, let's say, 2. This is not true, right? That's why answer choice A is actually, in fact, an incorrect answer choice. Now, you would plug in every answer choice like this, and you would just simply check which one is true. But we have decimals for this, and it will make everything way easier. That's why I'm trying to teach you the decimals method. Let me first of all make my screen a bit smaller, and let's just write our equations. The first one is y is less than negative 2 over 3, x plus 4, and the second one is y is greater than 2 over 3x minus 2. Because we have two lines, for us, as I said previously, a solution is considered the area when both of the colors fall. So this will be basically like this part, starting from here and slowly raising. This is our solutions. Now, let me tell you a life hack. Click this plus button, create a table, and just write in the coordinates. Let's pick coordinate 6 and 0. As we can see, this coordinate, it falls on the green line, and specifically it falls on the border of green line. And in this case, because the border is like full of dashes, we cannot count it as a solution. But the second factor is it only falls on the green line. We need it to fall on both of the lines. Answer choice A is out. Let's plug in answer choice B. So it will be 0 and negative 2. Now, this would be true if our lines were like this, because it would fall on a border where both lines intersect. This would be considered true. But because unfortunately our signs are a bit different, red dot falls on the border which are full of dashes. So we cannot again consider it as a solution. Answer choice B goes away. Let's plug in answer choice C. Answer choice C falls only on the purple part. Again, it goes away, and we are left with only answer choice D. In this case, as you can see, it falls on the place where both the purple and the green line basically fall on each other. That's it. The correct answer will be answer choice D. Now, let's do the same thing, but right now we will solve question number 2. Let me open Desmos and let me clear this. So it will be y is greater than 20. I'm sorry. Okay, this y. And 3x plus y is less than 25. Again, we have two equations. Let's read the question. The point x and 42 is a solution to the system of inequalities. Which of the following could be the value of x? Now, 42 is our y value and x is our x value. Again, let me open up a table and let me write 42 for y. And I will simply plug in one of these answer choices for the value of x. Let's start with answer choice A, negative 8. As I can see, I got a little bit lucky. Negative 8, it falls both on the green line and both on the purple line. Perfect. It is considered our solution. But let's just in case check answer choice B. And as we can see, answer choice B would just fall on a green line, which is not suitable. So the correct answer is answer choice A. Great. I hope you understood it. And let's solve one more question, which is this question right here. Again, let me open up Desmos for this. So simply, all I have to do now is write y is greater than 7x minus 4 and plug in those coordinates. Let's start with answer choice A. So 3, 13, 5, and 27, 8, and 48. Now, as I can see, let me open Desmos again. Let me make it a bit bigger so that you can see. These three dots, they don't even fall on our line. So these are not considered our solutions. Answer choice A goes out. Let's, for example, try answer choice B. The x values for every single answer choice is the same, so I will just rewrite the y values. So let's start with 17, 31, and 52. As we can see, because our borders, again, they are basically a bunch of dashes, and these dots, they fall on our border. We cannot count it as our solution. Answer choice B also goes away. Let's finally try answer choice C. So 21, 28, and 52. Now, this dot falls on the border, and this dot is outside of our function, as you can see. Let me just zoom in. So C is not the correct answer. We have only answer choice D left. So let's check it. It will be 35 and 56. And if we zoom in, as you can see, in this case, these three dots are not touching the borders. They might look that they're touching, but they're not. So answer choice D is our correct answer. I hope you enjoyed this video and I hope you understood everything, and thank you for watching.